All right, so we've learned about the conic sections and equations to describe those conic sections. And for all of them, they have foci. Ellipses have foci, two of them on the inside. Hyperbolas have two foci on the outside, and a parabola has one focus. We're going to ignore circles for the moment just because they're kind of boring. Not that they're not important, but what I want to do is take a minute to talk about reflective properties of these shapes and how those can then lead to interesting applications. So first, let's look at the ellipse. So the ellipse, what you've got here in this drawing is in this whatever you call this in this GeoGebra demonstration, we've got an ellipse that we can kind of change the shape of a little bit. So here I'm kind of moving things around. Let's see, can I move the can't quite, yeah, I can move where the foci are and that kind of thing. And it's kind of, there's this point that's moving around on the inside. It's this yellow point here. And I can move that yellow point back and forth. The yellow point represents a light source or a sound source, something like that, some source of waves that will be bouncing off the surface of the ellipse. You can imagine maybe we're inside a room, which is elliptical in shape and it has mirrors all the way around it. And the light coming from this source here is bouncing off of those mirrors. And right now, with that light source in the middle of the room, it's pretty chaotic where the light bounces. But if we move the light source to one of the foci, all the light beams are going to bounce off the walls and get directed straight back towards the other focus. So this is the cool reflective property of ellipses, which is that light placed at one focus will get bounced and directed straight towards the other focus. So one cool example of this being put to use is in something called a whispering gallery. Whispering gallery is like a big room or sometimes a space just beneath a dome in a cathedral, where if you stand on one side and whisper, the whispers can be heard on the other side. Now, there's more than one phenomenon which can produce this effect, but one of them, where is it? One of them is the ellipsoid or ellipse-shaped room. So there's a little image here. If you have a room which is a dome, which is shaped like an ellipse, so this is sort of oriented vertically, then if you have two people standing at either end at the foci, if they whisper, the sound waves bounce off of the ellipse and are directed straight over to the other focus location. So you can whisper very quietly, and all that sound actually gets directed and bounced and echoed kind of over to the other location. So you can hear each other, even though you may be standing very far away. You can hear each other's voices as if you were standing right next to each other. It's pretty cool, and you can come up with all kinds of neat little mystery story scenarios that you might use this, people sharing secrets and that kind of thing. So it's sort of fun. So that is one of the applications of an ellipse. If we look at a hyperbola, things are a little bit different. So again, we have our light source, and then now the light is bouncing off the hyperbola. Let's put the light source at one of the foci. So here the light source is over here at the foci on the left. And what happens is the light rays will bounce off of this hyperbola curve, and then they'll be bounced away along the slightly thicker lines. They'll be bounced away. They're not going in a straight line, but what they are doing is bouncing away, directly away from the other focus. So basically, a hyperbola, instead of reflecting light straight towards another focus, it reflects the light or waves directly away from the other focus in straight lines radiating away from it. So you can if we put the light source at this focus on the right, and when those light rays bounce off of this hyperbola, they're going to be bouncing straight away from the other focus. If you ignore the hyperbola segment on the right, if you get rid of that leg of the hyperbola and just have the light rays bouncing off of this hyperbola, the one that's sort of convex over here, when it bounces off of there, again, they're going to be bouncing straight away from the other focus, which is behind the mirror. So that can be put to use sometimes in certain applications. Don't really know anything off the top of my head. But the third one, the parabola, is actually kind of more interesting than either of them. The parabola is, I think, the most interesting example. So we have only one focus in this case, right there. If we stick our light source right at that focus, what happens is the light will radiate out and bounce off of the parabola, and then bounce in a straight line straight away from the directrix. So all of the light beams would then be traveling parallel to one another, directly away, perpendicular to our directrix. So it's sort of parallel to this line of symmetry that runs through the middle here. So that can be put to use in something like a flashlight. If you have a reflective parabolic mirror inside of your flashlight, then you can take the light, bounce it off the parabola, and direct all of it in like a beam, which goes. So all the light beams are traveling parallel to one another in whatever direction you point the light. So that can be useful. You can also use this in reverse, where if you point a parabolic mirror up at the sun, and the sun beams are coming down approximately parallel to each other, the sun beams will all come and hit the parabola and bounce back straight towards the focus, and you'll be focusing all of the light in one position. Which is why it's called a focus, by the way. Like this reflective stuff explains why we call these things foci, right? So I wanted to show you something cool. Here we go. I wanted to show you something cool. So this, let's see, do that. This is an example of someone using a parabolic mirror. So this is a circular mirror, but the cross section is in the shape of a parabola. And the sun reflecting off of this mirror, all the sunlight is being focused in this location here where the focus is. And you can actually like light things on fire with a parabolic mirror, or you can use it to warm something. People will use these to like warm up a tank of water, or you can use it as like a boiler, right? This is essentially like an alternative energy source. It's using the sun's light to directly heat something up by focusing all the light beams into a single point. So that's got a lot of neat applications. Another thing you could do this with is satellite signals. You can use the parabolic mirror to reflect signals from a satellite to a receiver, or do the opposite. So emit a signal from a point, bounce it off of a parabolic mirror, and then direct it out towards space so that it hits a satellite or something out there. This is how satellite communication works, is using mirrors, like conic section mirrors, parabolic mirrors, and other types of mirrors. So yeah, tons of cool applications for these things all over the place. So you can Google this and find a lot of other examples. The one last thing I wanted to show you is not so much about reflection, but I did a little Googling and found some information about applications of hyperbolas. So I wanted to kind of run through this and show you some of these. Shapes like this are often used in architecture, in part because they're pleasing, but also because they have like neat structural properties. So I'm going to scroll down here to another example, which is cooling towers. Cooling towers. Turns out that cooling towers are made in the shape of hyperbolas that are revolved around. And part of the reason for that is because it reduces the amount of material required. You can make a very strong hyperbolic shape out of straight beams. If you take a bunch of straight bars like this and kind of tilt them so that they're all kind of leaning on each other, then they form a hyperbola. So this curve along the edge here is a hyperbola. And so that is an efficient structure when building a very large tube, like essentially a cooling tower is just a really big, large tube. And so it's structurally sound, it's resistant to wind, and it has a very low material cost. So that is why they use them in architecture. Other applications of hyperbolas. So this one here, when you have a sonic boom, when a plane travels faster than the speed of sound, it produces a sonic boom, and there's a shock wave, which is in the shape of a cone. And as we know, a cone intersecting with a plane, such as the ground, produces a conic section. So in this case, the curve where the shock wave hits the ground is in the shape of a hyperbola down there. Hyperbolic shapes are also used in gears. If you need to put some gears together at some funny angle that's not parallel but also not perpendicular, if you have a skew angle, then hyperbola-shaped gears can allow rotation to be transferred from one axis to another along whatever angle you want. and variable angles as well. These things can actually sort of rotate with respect to one another, and you can and they continue to function as gears, which is pretty darn cool. So you got that. You've got light shining on a wall produces hyperbola shapes, and then I think there was one more at the bottom here. I wanted to show you. I forgot what it was. Oh yeah, so the one at stones in a lake. When you throw two stones in a lake and their ripples go out in circles, the the points where those circles intersect each other will form a hyperbola shape. So I'll share links to all these things with you on DeepL, and you can check them out. This video is getting kind of long, so I'm going to stop now. And this is the last video for this chapter, so I hope you've enjoyed. And yeah, I'll be putting up an assignment about conic sections.